Okay, act surprised. So, hey, amplifying F sharp, all that. We're doing our F sharp essentials lecture. This is something next month. Just hit your email address in this thing, and we'll let you know when it starts. This is really for newcomers to F sharp, people who have some coding experience and want to learn a language. In depth, we have I'm Russell and Edgar, who will be your instructors. Very interesting stuff. For today's session, we're going to talk about a new way to generate bindings for Fable. I will not pronounce it just yet, but a bit of a tease. And I'll just stop sharing screens altogether and give it over to Maxime. Happy to have you.
Thank you. So I will teach everyone how I pronounce the name of this project then. So I pronounce it Glutinium, like with a Latin word. It's so coming from the glue. So it's trying to glue F sharp and TypeScript together. I think I'm sharing my screen now. Can you just confirm that it's okay? Florian?
Yep.
Okay. And so the goal of this session is to present to you this project and also demonstrate how you can contribute to it. For people who came up to Fable Speak a few weeks ago, it's going to be much easier because in this case we are really early in the project and it's only F sharp related code. So we don't do crazy compiler stuff yet. So what is Glutinium? Glutinium is a project which take on TS2 Fable with a goal to transform TypeScript definition file into Fable bindings, which will allow people to consume JavaScript API in a safe way inside of their Fable project. I will use my blog post as a guide for me to present why I created a new tool and didn't update TS2 Fable for this goal. So the main difference between TS2 Fable and Glutinium is that Glutinium tries to use a new feature of Fable and F sharp and understand TypeScript as much as possible. So one of the examples for it is Fable use a lot of union type to represent union type from TypeScript and JavaScript, as it is common in JavaScript to have a function which accepts a string, a number, and a Boolean, for example, and they use a union type to do that. We don't really do that in F sharp. In general, we prefer method overloading. So this is how Glutinium is trying to translate them in this case. I have an example here. So for example, here we have a method which takes a string and a local. And TS2 Fable by default transform it as like that, which is not really friendly for F sharp. And Glutinium goal will be to transform it using overloading, so like that it's transparent for the user. Another example is when working with enumeration types. TS2 Fable generate a union type when we do composition or inheritance, like we can see here. In the case of Glutinium, it understands it more deeply, and in this case, it's able to enlarge the values directly, so you don't need to do U2 mapping, and it means that you have a much direct access to it, and you can do pattern matching on this type easily, which you can't do on this type, for example. The last point in understanding TypeScript is the utilities aspect of TypeScript, because TypeScript developers and TypeScript type system loves to invent new ways of making your code more complex. So for example, they have a lot of utilities like key of, exclude, pick, and so on, which does some compiler magic. And so Glutinium is trying to understand that. And in this case, for example, you have an interface with two properties, y, x and y, and a type p, which is of key of p. And what TypeScript is going to generate is a union of y and x here as the values. In the case of stereotypable, it generates the correct interpretation in the sense that this is indeed a list of strings that we want, or a string for the type P, but it's not really usable as easily. So in the case of Glutinium, what we do is we understand what TypeScript compiler is going to generate, and we inline the value once again as a string enum. So we have the interface point, and you have P which accepts X and Y, and if there was another properties, it will add it here with the other one as a name. The reason why I created a new tool is because Fable is kind of old now. It's all 6 or 7 years old almost, and so there is a lot of bindings that already exist, like for the browser and existing libraries. And I don't want to break the ecosystem by making a new update of a Fable browser library update, for example. And the way to avoid that I found is to say, if we have the old bindings and we create a new ecosystem called Glutinium, then we can have them evolve side by side and have people migrate over time to the new bindings if they feel like they are better. So the goal is really to not break existing code and try to be conservative on this subject, because it's always difficult to break really low level libraries. So that was my first 2 points on my list. Now we are going to go to the code. So if you want to look at the Glutinium tool, there is a repo called glutinium.org with CLI. CLI being the tool that you use to transform between TypeScript definition to F#. So you can go there and you will see the issue list and all the other stuff that we will go over during this session. And now I'm going to give you an introduction into how everything works and the architecture of this project. So what do I have inside of the README? Yeah, so inside of the README, you have some explanation about the structure of the project, which I'm going to cover, and also some explanation on how to run the project and some tips if you want to contribute that you can look to later. So inside of the project, we have a source repository, which contains 3 projects: build, converter, and CLI. Build is just a build system, like a makefile or a fake script, if you want, which orchestrates everything that happens inside of this repository. So for example, when you run build.sh, it's going to use this project to give you a list of everything that you can do. So for example, you can have access to the test commands with a watch option. For example, you can build a local CLI tool if you want to test the tool locally, and some helpers for maintainers like myself to publish and link to the code, for example. The next project that we have is the converter CLI. This project is only a small wrapper that is going to use Glutinium converter with the goal to translate your command line arguments into something that the converter understands. So it's really a simple file which is going to give you a usage or guide on how to use the CLI tool. So you can have some examples and the list of arguments with the options. And we parse them below in the main file in a really simple way, to say it like that for now. And it works okay. So we keep it like that for now. This is not what is really interesting in this project. The third project is Glutinium converter. This one is where all the logic of Glutinium is, and where we are going to spend a bit of time. So the converter is responsible for understanding the TypeScript IST, and the goal is to transform the TypeScript IST into Glue IST, which is kind of like a more F# friendly IST that we will be able to use discriminated union and active pattern matching on it to work, which is going to make our life easier, because otherwise we will just use if statement, which is not really easy to do and not exhaustive. Then once we have the Glutinium IST, what we want to do is we are going to transform this IST into an F#/Fable IST. I say Fable because this is kind of an opinionated IST that we use to make our life easier to generate the final code. And at the output, we have the F# code, which is what you get back from the tooling and what you want to include into your binding or into your project, for example. The TypeScript IST is coming from TypeScript directly, and we have a TypeScript binding, which is located inside of this TypeScript file. And it contains all the definition that TypeScript has in theory, and most of the time you are going to spend it using the syntax guide. Can I go to the definition? Type enumeration. So you can see that this is an enumeration with all the different values. And so if you get one, it means that this is the end of the file, for example. And this is how you traverse a TypeScript IST. And it's not really easy to use, and it doesn't have a lot of information. So we want to transform it into a Glutinium IST, which is going to be this type here, where we say a Glutinium type can be discarded. It's kind of like we don't support it right now, but it can, for example, be an interface. And in this case, we have all the information that we want for the interface on the Glue interface type. So for example, an interface has a name, some members, and type parameters. And we can go deeper into a Glutinium member is a method, a property, a call signature, and index signature, for example. Something to note with the Glutinium IST is it's trying to stick to the naming convention of the TypeScript IST because it's trying to kind of represent how TypeScript works. And so, for example, call signature and index signature are names that are coming from the TypeScript IST. You can see it here, for example. And so in our case, we add more information to it to prepare the data. The F-sharp IST is kind of the same as the Glutinium IST. So it's related to F-sharp. So now everything is named based on F-sharp naming convention, more like. So for example, we can have an interface, which is an F-sharp interface. And in F-sharp, an interface can have some attributes, a name, a members, and type parameters. So we can see that in our case, we added some more information like attributes, which is not present inside of the Glutinium IST. And F-sharp attribute is where we are pretty more primitive than F-sharp attributes definition in the IST. In F-sharp, an attribute is more or less a text. And in our case, we create specific attributes to represent the available ones, like an import statement, which accepts the name of the package or the path we could, or the name of the thing they want to import, and the path of the package, for example, or you have the erase attribute from Fable too. And we generate specific one like emit self interrupt invoke, which avoid us to have to write emit $0 $1 every time we want to access the attribute or define it. It's easier to have this helper. Yeah. So how do we play with all these attributes? What we do is we have a read stage. So this is where sorry, not a reader, it's a generate function. So the generate function is taking a file path, and right now it's going to set up the TypeScript compiler with minimal options. And once you have all the TypeScript checker, what we do is we are going to read the source file using that checker, which is a type checker from TypeScript. And so all the reader code is located inside of the reader folder, like here. And what we do is we have a TypeScript reader, which accepts the checker so we can access it more or less everywhere in the code. And on this type, we define the contract using an interface or an abstract class in this case. And this allows us to split this reader into smaller files because otherwise we are going to need a lot of recursive functions. And it started to be really a big file, like a 2,000 or 3,000 line of code, and it keep going on. So it's easier to have smaller files, like we can take, for example, the name declaration. I'm going to close the console for now. So we have only one function in it, which accepts the reader and the declaration that we try to work with. And then we match on the declaration and we try to understand what TypeScript information is available. So we have the name, for example, the property signature, and so on. And the goal is to output a Glutinium IST information. So here we had to put a Glutinium member property with the name that we found, with the type and some information. And we can, inside of these readers, use other readers by using the reader parameters or arguments. So on reader, I can access with the type neutre because it was defined on the abstract class, for example. Once we got this read, what we do is we are going to transform the IST. So the goal is to transform the IST from Glutinium IST to F-sharp IST. So if we go into the transform definition and we look at one of them, like interface, for example, or class definition, class declaration in this case, what we do is we say we got a Glutinium class declaration information and we want to output an F-sharp type. So we do the transformation. So we want to generate here for the class to represent it using an interface with some attributes. So attribute null literal, for example, because in TypeScript and JavaScript, most of the stuff are nullable. We convert the name, we convert the members and the type parameters. So for example, here we have on the class definition declaration a list of members and we can call transform members and it's going to transform a Glutinium method into an F-sharp method, for example, and so on for all the different cases. The good thing with this structure is the more, for both of them, this file, the more syntax we support, the easier it is to work with code in theory, because we have access to more helpers, like for example, transform members is used at two different places. So if once I did it once, I was able to reuse it to transform an interface in this case, for example. So the more we contribute, the easier it is to work on it. And once we have the transformation done, if we go back to the generator, what we are going to do is we are going to call the printer module, which is going to transverse the F-sharp IST, and it's going to output the F-sharp code. So if we go to the printer, which is here, we can see that for, where is it? For an interface, if we want to print an F-sharp interface, it's going to do a lot of string concatenation. So it's going to print the attributes, then the type with the name of the interface, some type parameters if there was any generics information, and it's going to print all the members, for example, with different cases, like is it a static members or an abstract definition. And this is where the code is a little bit less readable because we do a lot of concatenation. But this is how we get out the binding code. The last project that we didn't mention is a test project, because with Glutinium, we try to have some specification for everything that we support. So inside of the test project, test folder, we have a spec file here, which is something that we don't need to touch. Basically, what it says is going to take all the files inside of the spec folder. It skips only the definition files, and it's for each definition file that it found, it's going to execute the Glutinium transformation, so the generic binding, and at the end, it's going to check if everything is equal. So we see it here. So if we go inside of the spec folder here and we take, for example, the interface, we can go to the read and write property. So here we can see an example of a small definition file that we want to work with. And under this file, there is a matching FSX file, which is what we expect as an output. So if we put it side by side, just trying to play with the window, we can see the original definition file in TypeScript, and this is what Glutinium is going to output. We add some nuggets include here, just so this FSX file doesn't have compilers errors in it. So we can check that everything is working correctly, and we can also get JSON if we need to adapt it or to play with the data. And for each specs, we have the same structure. So if you go to call signature, we have a call signature F# file below it. I'm just checking my notes. So that's a quick tour of the project. The goal now is going to explain how you can contribute, and for doing that, we are going to look at an issue and start from the issue, add the specs to the project, and work our way through the code to support this feature. So if I go back to the Glutinium project, we can see that we have some issues, and I saved in one. I closed it because I already did the exercise on my side before, but we are going to do as if it was not implemented yet. So inside of the issue, in general, the goal is to have the TypeScript documentation or definition and the equivalent code that we want to generate for it. So like that, if someone wants to contribute, they don't need to know about Fable or anything like that, and we already agreed as a community onto the representation or translation that we want to do. It's often also useful to have the npm package that can use this feature. This is so if we get a translation layer, we can test out our translation is working, because sometimes we can want to do something and perhaps this is not the correct way to represent it. So here, if we want to work on this issue, what we do is we take the TypeScript definition and we are going to create a new specs. So in this case, it's going to be an interface with a method. So I'm going to, I'm mixing both file names here. We create a method DTS file, which contains the definition. And we can create the equivalent F# file for it. I think when I was reading, I saw that Florian submitted a way to write the file the first time that we generate it, but I never tested it out, so I'm not going to give it a try yet in live. So here we can say we want to generate something which looks like that. So I'm going to copy paste the code. And what we want to do is we are going to, if you use VS Code, we are going to use a special terminal. So if you go into the debug tab, what you can do is you can open a JavaScript debug terminal. What it does is that any JavaScript process that you spawn will have a debugger attached to it. And in our case, this is going to be handy because we will be able to attach a debugger inside of the Glutinium instance that we are working on to inspect what we get inside of the TypeScript or memory. So we can do build, test, watch, and what we can provide arguments to the test framework to target a specific test. So we can target interface method, for example. So it's going to build the test suite and run it. And right now it's going to fail because we don't support this syntax yet. So what we can see is there was an error while reading the name declaration in this file. We got the unsupported syntax code, which is the TypeScript syntax code, and we get a local text and the parent text to give us a bit more context. So we know this is the text that failed, and we know that it was inside of this context because sometimes you can have the same line occurring at different places in your definition files. Sorry. Because with Fable we can activate source maps. It means that if I click on this error here, Node.js was able to map it to the original location where the error occurred. So I know that this is where I need to start working with the code. And this is confirmed by the fact that there was an error reading name declaration. And this is what we see here, for example. So what we can do is we can create a temporary variable and make a debugger point. So like that, here I have the JavaScript debugger attached at this point on the code, and I can inspect what I have available inside of the debugger. So if we go up, we can see that there is something called declaration, and we can hover it, and we can have some information about it. We know the kind of it, which is 173, which is the declaration which is failing. We can guess that there is a name, because there is a name property which is filled, and if we explore it, we see that this is the hello name. And we see that there is a type, so there will probably need to be a type output. And there is also some parameters array. Here it's empty, but it's kind of hint us that we will need to support parameters for this type of declaration in the future. Another handy tool to work with the TypeScript IST, because sometimes you don't really know what is the structure of the IST as a global, is to use TypeScript IST viewer, I think it is called, like here. So if you pass in the code and you select the correct version of the TypeScript compiler that we use, right now we are on 5.2.2, what we can see is a visual representation of the TypeScript IST. So this is a source file with an interface declaration with an identifier. And in our case, what was failing was this current 173, which is a method signature, which has an identifier. And here it's a string keyword, which is kind of the type we can guess that we will get from it. So it's really handy to have this IST viewer, because like that we would kind of know how you need to unwrap the TypeScript IST and what kind of information you can get access to. So if we go back to our code, I'm going to close this file. We can go back to the name declaration, and what we are going to say is here we want to support TS syntax kind, and it was called, if we check here, a method signature. So this is where the tool is also handy. Make a method signature. Going to remove the debugger tool to get IntelliSense, perhaps. And if we can also check this is the correct one by going to the definition, which is 173. So in that case, what we want to do is we want to say method signature, and we cast it into a method signature. Like that, we kind of narrow down what type of properties we have access to at this point in the code. And then what we want to do is we will need to check if method signature is already inside of the Glutinium IST or not. So we can go to the Glutinium member information, and we can see that method signature is not here. We have method, but this is not exactly the same. So we can add method signature of Glutinium method signature. And we are going to create this type here. When looking at the type earlier in the memory, we saw that we wanted to have a name, probably a list of parameters, and a type as an output. So this is what we want for as information for the Glutinium method signature type for now. So we can save it, and we can use this type that we just created inside of the code. So here we have some errors. So here for the name, this is because property name is one of these types that is a union type. So if we go to the definition, this is a union of 5 of all these different classes. So for now, what we do is we kind of unwrap it in a forced way. We will see later if we can find a better way in the future to do it. So we do a method signature to get the name, and we do name get text. And for the type, we have an error here. Because type was already an option, so we were creating an option of an option, which is not what we want. When we want to read the type node, we want just an option of one level, and it's going to do it for us. So now if I save the file and look at the console, I think I crashed the console because it's a bit too big. Just going to restart it. We will see that we have an error, but now it's a match failure. It's because we didn't add the match case to the transform layer. But what we can see is that in debug mode, we get access to the Glutinium IST output, kind of, and we can see what we generated. So we can have a feeling if we generated something correctly. So we have a name, which is local. And when we look at the method DTS file, this is the name of the interface. Then we have a method signature call with the name of hello, which seems to be correct because here it's hello. We don't have parameters, which seems to be correct because right now there is none. And the output type is a primitive or type string because this is a string right now. So this seems to be okay. So the next step is to teach the translation layer, transform layer, how to transform this Glutinium IST into an F-sharp type. So if we go there, we can see that there is an incomplete pattern match, and this is why we transform the IST from TypeScript to the Glutinium, because like that we can have the compiler having your back here. And so what we want to do is we are going to add a new case here, which is glue member.method signature. And we are going to let compiler generate it for us and check what it generated. So it says that it wants to create a F-sharp method, which seems to be okay to me. It doesn't have any attributes for now. We take the name and we escape it. So if the name has some clashes, we are going to add a specific instruction to it. We transform the list of parameters, we transform the types, and there was no generic, it's not optional, and it is not a static method. There is no accessor because this is not a property and it's public. So it's visible outside of the class. Now, if we save the file again and look at the output, what we will see is we will see a Glutinium IST, and we will also see the F-sharp IST that we generated, so we can check that the translation happened correctly. So name is local in both cases. We do have a method named hello with an output type of type string, for example. What we can see in the output here is that the printer was able to work with the new type that we added because it was already knowing the F-sharp method. But the expected output is not exactly what we wanted right now. So we need to fix our expected output. So what we are going to do is copy paste some code on. So we want to create the module and open some statements and create the type here with the suffix for the NuGet informations. And also Glutinium is using the member, non-optional member syntax here. So we need to generate abstract member hello. And if we run the test again by saving an F-sharp file, we will see that now the test is passing. So we added support for a new syntax to Glutinium, but we are not done yet because thanks to pattern matching, we can see that, where is it? In the transform layer, we have some warnings because here, for example, it says that there is an incomplete pattern match on this expression. So we need to teach it how to handle the method signature. And we have the same case happening below here when it's trying to get the type information. So for this one, it's pretty easy. we just look at what we do above and we do the same thing. So like that, we were able to extract the type from it. And here, for the transformation of the key-off, if we look at the code, we can see that there is different case. There is a method and property where we extract the case name, and the call of signature and index signature where we don't do anything because they don't have any name for them. So in our case, we can guess that because we have a name, we should add it here. So we handle it. And what it means is we are going to need to add new test to our new specification to cover this new case that we added here. This case is going to be a transformation of key-off. So we can go to key-off simple object. And in our case, we are going to add method.dts, for example. And we can take this method and add it here. We can give a try to having the expected output generated for us. Well, actually, it's not going to work because I need to focus on the correct test. I need to focus on key of method. And I hope I did the correct thing because I don't remember what I was expecting to do, required to do here. Oh, it was with the argument that I did it. Well, we will see if it works or not. Test finished without running any test. Oh, because it's generating inside of the dump file. So now we can see the output that it generated. It generated a local of this type, but it's missing the key off. Yes, because I didn't add the key off here. So we can give it a try to generate it again. I'm kind of going off script here, so I'm trying to stress a little bit. If we go to the method of key-off, yeah. So it generated a temporary file, which looks okay to us. And so what we can do is we can transform it into an FSX file if we accept it. So now it's going to be the expected output for the method test. So we have the interface happening, and we do have a string enum generated with the name of the method. Yeah. So it should be okay comparing to what we understand from TypeScript. And what we can add too is because we described, where is it? In the Glutinium interface, we described method signature to have some parameters, but we didn't test this out. What we can do is we can add a test for it. So if we go to interface here, we can do method with arguments .dts, and we can say hello name string and prefix of type. I never know which one I need to use in TypeScript, but Boolean, like this one. And we can focus on this test again. So method with something. And we will wait for the test to propose a file generation and see if it's looking good. And if it does, then we can accept it. I did the same mistake as always. I updated the wrong file. So if we update this file and run the test again, We can see that we have a method named hello with two arguments. One of them is name with string, and the prefix is not exactly what we would like to generate, because in F# what we would like to generate is actually an optional argument like that. So we need to do the translation for that, and we need to look at where the problem is coming from. What we can do is we can look at the IST. We can see that the F# IST had two arguments. So one of them was named name, which was okay to generate, and the second one was named prefix, and it was actually marked as optional. So what's happening is it's probably the printer which doesn't generate the correct output for the code. So we can look into the printer code. And inside of the printer code, what we can see is if we go into interface, members, and F# method, because this is what we are working with, we can see that there is a check here to say if it was optional or not, then we want to add a question mark. But we did this only, I'm to zoom in to show everything at once. But we do it only if it's static. So if it's not static, what we do is if it's optional, we generate an option at the end of it, which is a mistake. What we should do is we should generate something similar to what was above, so we can replace the code with this. And I think it's going to generate the correct one. And so now the test is passing because I fixed the expected output, which was with a question mark, and now it's generating the correct output. So this was a showcase of how to debug the printer output, for example. Because we do a lot of concatenation, it's easy to get lost in which places we are at the generation. So we go slowly from there. And once you have this done, you should create a pull request to Glutinium, send it, and then people will be able to validate it. So the maintainers can validate the pull request. And if you want to check if your change improves your situation based on your own bindings, what you can do is you can, using the build sh file, you can build the CLI tool. So using build sh CLI, so it's going to build the tool locally for you. And then what you can do is you can call node CLI.js, and you have access to the Glutinium tool locally, so your own instance of it. So you have here, for example, with the help manual, the usage manual, which is shown. And what you can do is you can test it out against your own bindings. So, but in our case, we are going to test it, for example, against the specs. So I'm just going to take one as random. So here, for example, yeah, there was no class to generate. And I take the disable state test. If we take the members, we can see the output of Glutinium, and you can pass it an out file arguments if you want to save the output to a file, for example. So this is one way to debug your complex definition files with a local build too, because sometimes it can take some time to get a release. I lost my thought. There was one thing I wanted to show. Yeah, well, we covered more or less a good scope of Glutinium, I think. What I wanted to say is what is the future of Glutinium? The future for Glutinium is to add more JavaScript or JavaScript syntax support, because it doesn't support everything yet. And also, we want to explore new ways to improve the developer experience. Because right now, if you want to use Glutinium, what you need to do is to invoke it using the npx tool, for example, from npm, or you can install it locally. For now, we probably recommend to invoke it like that, so you get always the latest version of Glutinium. But in the future, what we want to provide is something similar to ts2fable, so a way for you to provide the TypeScript definition file on the left. Or if we take this file, for example, you can pass it on the left and get the output on the right, which is always handy to have a quick look at what you could have as a generated output. And other idea is to provide a user experience similar to Bundlephobia, where you could search for a package. So for example, you can search for DJS and you click on the package and then it's going to do some magic stuff for you and give you back either a textual output or a zip file that you can include in your project with project files and everything set up for you. That's also another way that we want to offer Glutinium in the future. And yeah, so if you try out Glutinium, be aware that this is still in early development, so it can crash. But if it crash, we are interested in having new issues opened for it. So you can go on the issues, create a new issue, and you can use our template to create an issue. So it's going to provide you with the information that we would like to have for it. And you can also look at existing issues and comment out if you have a particular case that is not covered yet, but was opened. And if you want to give a try to fixing an issue, you can also pick an issue at random and, if possible, add a command saying that you want to work on it. So we avoid working on the same issue with several people. And yeah, from there, I hope that I have shown you that working or contributing to Glutinium is nothing too complex, and it's more like working with a normal F# code base, and you don't really need to learn about all the detail about Fable and TypeScript. Like it's a minimal knowledge of TypeScript, like the fact that you can look at the debugger to get the name and the different information that you would like is more or less all that you need. If you have any questions, well, I will be happy to take them now because I think I spoke a lot. And there is question about what Glutinium can do and or anything you want to ask us question, we can answer them. I see only the Zoom chat. So if you have the YouTube chat open, or if I can find the link, perhaps.
Nothing yet on YouTube. I think so. I'm monitoring YouTube and we don't have any questions there.
Okay.
So
There is no
out of
question. It means
interest,
that I was. Yeah, go on. I was going to say if there is no question, it means that everything is clear and I did a good job.
yeah, for sure. Thank you, Masimi. That really was very, very straightforward to follow. It's F sharp. You know the stuff. It maps one thing to the other, and then it takes an input, has an output. So it's really a fun project to work on. I was kind of wondering what your approach is into converting one binding. So we saw that you can run the CLI locally. Are you specifically working on certain Node packages that you're trying to convert, or are you just trying to support syntax in general, or what's your personal take on it?
So right now, what I did is I took a library that I know that I used in the past, which was not too big but not too small either. So the goal is to take the JS binding file, which has a bunch of different syntax in it, and to try to generate the best output for it. We are more or less there. We covered perhaps 90% of the ground. And once this is done, the goal is to look for another binding which use specific syntax that I don't have, like for example, imports. This is one of the big support that we want to add. The fact that in TypeScript you can import types from another file. So we want to look into how we can support that. Can we discover it and generate the binding for this external or additional file too? This is something we want to explore. So this is a general approach that I have. And also, it's also based on my experience using Fable, because I know that in the past there was some bindings that I generated with TS2 Fable, which used union type. And now that I know we can work on this limitation, I want to remember this binding and revisit them and see if Glutinium can do something better in this situation. Just to be clear, if you work with Fable bindings right now, you probably want to give a try to Glutinium just to report an issue, because this is more likely than what is going to happen. And then you can go back to TS2 Fable, and once Glutinium is going to be more mature, then it's going to be able to replace TS2 Fable, but it's not yet there. But that's the goal. Something that I forget to mention is for Glutinium is we want to offer a plugin interface to Glutinium, because for some bindings, you are going to need to generate something specific in the code. Like for example, if you generate a React binding, you are going to want to switch the generation of the code to use something like the Feliz DSL. So you don't want to use interface in this case, you want to use type with static members. So because we can't support every single type of output, because if we start supporting React, some people will want to support Solid.js or Vue.js and so on. For this kind of goal, we want to explore providing a plugin interface so people can plug in like the React plugin. And so if it detects a React element, it's going to switch the type of output we generate. That's the idea.
Yes, that's really interesting. So would the one possible future be that you have a npm project, the package JSON, you have a bunch of dependencies, stuff you use, and then all those bring their own TypeScript definition files. You run the tool locally, and you have bindings for everything that you use in a specific project?
That's the end goal. Like if we are really optimistic, it's doable for the fact that Axe, another transpiler, does it for their own bindings, but they have one major benefit compared to us, which is they are a C language family language. So it's much easier to make bindings for TypeScript because it's sharing a lot of in common with the syntax. So yeah, if we are able to have a really high level understanding of TypeScript and make bindings for balls that work really well with that, perhaps one day we will be able to just generate bindings on site, like you have your project and you provide, you invoke the CLI and it discover every binding that you can generate and generate them for you. But it only works if we can generate bindings that work directly, and you don't need to modify them every time to regenerate them, for example.
But in that utopian future, it would really be a sweet spot, because when you update an npm package, you just regenerate the bindings, and in theory,
Yes.
it shows you what broke in your own F# code.
Yeah, and it also offers new possibilities, because like if we go into one of the issues that I opened, there is one of them which is called param object, which is a new way to represent Pojo in JavaScript. And so the idea is, if you have this kind of interface in TypeScript, it's common for them to be Pojo and not an API binding. So you want to be able to create this, the JavaScript equivalent, which is something like first name Sergey and last name, something like that. So it's not a binding about type dot first name. It's not only that, for example. And the goal with that, I was thinking at first, like most of the times they use option as a suffix. So I said, well, at the first implementation level, we can just detect if it's option suffixed with option, then it's going to be good enough. And then I worked on another binding, which doesn't use option suffix, so you can't detect it as naively. So in this case, what you need to do is you need to detect that this interface type is used or called by a function in TypeScript, for example. So you need to detect how it's used, so you know what to generate. And this works as long as your type definition is inside of the same package, because if it's in another binding or npm package, then you don't have access to the information yet, unless we do what we said just earlier, which is discovering all the package dependencies that you have and work on all the npm package at once to discover every usage of the type, for example, across the npm packages. So yeah, it's not only better, but it's also allow us to support a different use case, which is then better. But yeah, before going there, we have a small road to travel. And so yeah, this is one of the issues if you want to have a look at it and how we can solve this kind of problem. I'm really open to it because now I propose a really naive approach using counters. So if someone has a better idea, please read it and comment out for this issue. So yeah. And in the same way, if you have ideas on how you want to consume or to create bindings, and we can improve your user experience, like providing something similar to testable or bundle phobia, and you have another idea which can be better perhaps, then we can perhaps use your idea instead. Like we are really welcoming feedbacks in general, and we listen to that, like we did with everything related to Fable in general, and we try to make the best with the community. Like even if you can't contribute to the code, it doesn't mean that you can't add value to a project. Like even commenting on an issue can be really valuable in general.
Exactly. That sounds like everybody that uses npm packages back at home has some homework. Just try out the tool, see what works, report some codes that you have in your projects that aren't there yet. That's already a great help to contribute.
I can see what VS Code type definitions spit out. That'll be a good test example as well.
Well, right now, it generates an empty file. It doesn't crash, so it's great. It just doesn't support import statements, so it does nothing for that. But yeah, actually, Glutinium was resurrected like 6 months ago because I wanted to create a VS Code extension, and I knew that we could do better than what we had, and so I said, "Oh, how hard can it be to create the binding for the VS Code?" And I started doing it manually, and was like, "Oh, it's really too long. I need a tool." And so now, yeah, I'm here with another side project, as if I didn't have enough already. But this is how we have some fun.
All right. I don't think we have any questions left in the chat. So going once, going twice, I would wrap it up here. Thank you again, Maxime, for this very great demonstration of the code base. I really hope people are encouraged now to try this out, to play with this, and then we'll probably see you again sometime this year.
Yeah, with pleasure. Thank you for having me.